Hey, welcome back to the high RPM turbo engine build. I know it's been a while since the last video, but as you can see, I've pretty much finished the engine, and this is what this episode is going to be about. Putting the cylinder head on, damper, degreeing the cams, and enjoy. Okay, so we're now going to be installing the oil pump. I went with the Boundary Engineering Stage 1 oil pump with billet gears because we're revving higher than stock, and we're also having a lot more torque and horsepower, so I think this is really a good pump for this build. I also think that the Stage 1 pump that this is just going to be fine for our application. As you can see, I've already installed the front main seal and also this O-ring on the back, which is also very important, of course. Now I'm just gonna apply the silicone sealant on this surface, and of course I already cleaned the block surface and the pump too. Okay, so I've pretty much applied the sealant now, and I'm gonna just put it on the crank. Just make sure that the gears just line up with your crank here, so it's easier to install. But you can do, once you got the pump on, you can just use a mallet to beat it. Now before I'm going to be torquing all the bolts, I'm just going to let the pump sit like this, because then the sealant can already get a little bit firm, and then just after a couple minutes I'm just going to torque it to the spec of 25 Newton meters. For the water pump, I have this paper gasket, and since I really don't want any leaks in this engine, I'm just gonna apply a very thin layer of sealant around here and around here, so that I can just make sure it's not gonna be leaking after I install it. Again, it's 25 Newton meters of torque. To get this timing gear on, we need this woodruff key, timing gear, and this gear here doesn't fit straight onto the crankshaft, so what I do is I already place the woodruff key inside, and then I will heat this up so it'll expand a little bit, and then I'll hammer it with a mallet in place, and then it'll stay there. We're getting closer and closer to putting the head on the engine, and one of the things we gotta do first is, of course, clean the deck surface so the head gasket will actually seal properly, and then also install these little locating dowels. One goes right here and one goes here, so the head gasket will stay on there properly. The next step is installing the head studs, because I'm going to be using ARP head studs. and they look like this. They actually do have a side that should face up, which is this one, and the side should face down, which is this one. And one thing that's important when mounting these is using the ARP ultra torque lube that usually is supplied with these things. So you just put some of that lube on the threads, just like we did it with the rod bolts, and then thread them in, only hand tight. By the way, one thing that's important when putting on your head gasket, of course, make sure everything's clean, but also the head gasket does have a direction. So this was the point where I saw this is the way it has to go onto the block, and just make sure you install the head gasket in the right way, because otherwise you're going to have your motor overheating before you even run it properly. As you can see, the cylinder head is now on the block, but there are a couple things I really have to pay attention to now. Before I put the cylinder head on the block, I put the crankshaft on the top dead center position, and then I aligned the camshafts where about the factory marks would be, which is this mark here showing up and this one also, but we need to degree the cams. It's going to be really important, but before we can do that, I have to put on the timing belt and also torque down these ARP head studs. So what I'm gonna have to do now is again use this lubricant for the threads again, and then I can put on the nuts and washers and torque that down to about 65 foot-pounds, which is 88 Newton meters. Now before I'm going to be torquing this with the final 88 Newton meters, I'm going to torque it in 3 steps. So I'm going to do 30, then 60, and then 88. And the order is like so. that's a lot better now.
Okay, now what makes this cylinder head so special? This is basically a NB 1.8 liter cylinder head, so it already had the solid lifters, but it has been converted to shim under bucket lifters because they're a lot better if you want to run high RPMs. And also I have the cat cams turbo conversion camshafts, which are 11.25 millimeter lift on the intake side and 10 millimeter lift on the exhaust side. I also have the full SuperTech valve train with stiffer springs, and I also got the SuperTech oversize exhaust and intake valves. So yeah, this thing should be pretty good. The only thing I didn't do was porting the cylinder head, so it's pretty much a fully built head with full crazy valve train stuff, but yeah, with adjustable cam gears also. But I didn't port it because it's already the NB head, and I think that's gonna be enough. But it's gonna be pretty crazy with a turbo, and it's gonna have a really nice idle, I'm hoping. Before I can actually degree the camshaft, I need to find true top dead center. Usually all of these engines, they do have a mark for top dead center. For example, here on the oil pump, and then another mark on the cam gears, but that's not accurate enough for us because we're gonna have to be finding the true top dead center. So what we do is take one of these dial gauges and an extension so it reaches down onto your piston, and then I'm gonna approach top dead center. As you can see, the gauge is already moving, so we're having contact with the piston, and I'm getting closer and closer to top dead center here, or where top dead center should be. And now the gauge is gonna go to the right because the piston is moving upwards, but there's gonna be a point when the piston's dwelling, so when the piston reaches the top, the indicator is gonna move less quickly, and also there's one point where it'll start move the other direction, and that's where the piston will go down again. I've turned the crankshaft multiple times to see what the highest reading on my gauge was, and it was always this reading here. So what I did was I took a small piece of TIG welding rod, aluminum rod, and then just bent it so I can bolt it to the water pump. And now if I look this direction, if I'm on my knees, I can see the top dead center right there with my pointer, and it pretty much aligns with the factory marks if I look at it. So that's how you find top dead center. Alright, so the first cam I want to degree is intake camshaft, and what we need to do for this is the method that the cat cams manufacturer wanted me to use to degree them is valve lift at top dead center. So what I have to do is I have to put the crank to top dead center and then make sure that the valve lift is the specified value that it says on the cam card, which is, by the way, 1.95 millimeters. Now what I have to do for this is find the lobe that would be opening the valve at top dead center for the intake, which would be the lobe on cylinder number 4, not number 1. And what I need to do first is get my dial indicator and make sure that it sits on the lifter. And as you can see, the lifter has an angle, so I have to make sure that the angle of this rod here matches with the angle of the lifter, otherwise I'll get inaccurate readings. And another thing that I need to do is I need to make sure the cam's on the base circle so it doesn't have any lift, just like right now. And then just zero the dial gauge. And what I also need to do is measure the valve lash, and I already do know the valve lash for this lobe here, which would be 0.2 millimeters. I'm just gonna have to find the feeler gauge for that right now. Just like this. Alright. And yeah, now I can pretty much start with the intake cam. I have to loosen these 5 bolts here and then make sure that the lift is in the right place. And since our valve lash is 0.2 millimeters and the lift that we should have is 1.95, the lift I'm gonna actually have to be providing with this tool here will be 1.75 millimeters, because my valve lash is 0.2 millimeters. So you always subtract the valve lash figure from your actual lift figure, because we have mechanical profiles here. Okay, so I have degreed the intake camshaft to the specified 1.95 millimeter lift, which actually was 1.75 millimeter because I had a valve lash of 0.2 millimeters. And now for the exhaust camshaft, what I have to do is put the crankshaft on the top dead center position so that the exhaust lobe here is just about to close the valve again. But before I could do that, of course I had to put my dial gauge to the lifter again. I'm measuring on the 4th cylinder, again just like with the intake cam, but this time, since I couldn't get on the lifter because of this this drive here for the cam angle sensor, I had to take a TIG welding rod, screw it into my extender here so I can reach around and actually be on the lifter. But now that I'm on the lifter and I have the right angle for the gauge, I zeroed it already on the base circle, I can now turn the crankshaft to top dead center. Okay, we're now on top dead center. We can see our mark aligns. And then when we check the gauge, we actually should be around here. So we're still not perfect. There's still about almost 15 millimeters to go, because the lift should be 0.35 millimeters, but since we have valve lash of 0.3 millimeters, we don't have to be at the 35 mark, but we actually have to be at the 005 mark. Now we can proceed to one of the final steps of putting this engine together, and now it's time to put on the oil pan. For that we need the 2 U-shaped lips. One goes on the oil pump and one goes right where the rear main seal goes. And then we have this baffle here, which is supposed to make the oil flow into the oil pan in a certain way. And first we need to seal this baffle.
Okay, now we can install the oil pump pickup tube. There's a little paper gasket that goes right in between the pickup tube and the oil pump. I'm now about to install my coolant reroute. I have this plate here, thermostat goes here, and then on top of this we will have this Kia water neck, and it's going to sit like this. So the water temperature sensor for the ECU will read the actual water temperature in the head, because the thermostat's going to be here, and if the thermostat would be here, then it would only read the temps when the thermostat starts to open. So the first thing I need to do is I would glue the thermostat with sealant in here, and I have a mark that I made because when you're bleeding the system it has to face up, because otherwise you're gonna have this much air in the system, and to put it this way, it's better for bleeding. So that's the first thing that I'm gonna do.